For months, scientists believed they understood the rhythm of 3I Atlas, a strange visitor from deep interstellar space approaching our sun, changing shape, brightening, dimming, behaving like nothing we have ever recorded before. But then, something happened. Something subtle, yet powerful enough to freeze entire research teams in silence. New observations revealed structures that should not exist, movements that defy celestial mechanics, and chemical signatures that reach far beyond the boundaries of what we call ordinary cosmic evolution. Tonight, you and I are stepping into that thin line between what science can explain and what it desperately hopes is still natural. Because the latest images from Hubble, amateur telescopes, and the ESA probe reveal clues that simply do not belong to a typical cometary body. And the closer 3I Atlas gets, the more undeniable its anomalies become. This is the moment when the world stops, when speculation becomes unavoidable, and when the universe whispers a reminder, we are not in control here. Something is approaching, and its message, whatever it is hidden inside its behavior, its fragments, and its unnerving precision. So sit tight, because what you're about to uncover may change the way you see every object that drifts between the stars. The first wave of shock came not from theory or speculation, but from raw, undeniable imagery. For the first time, humanity captured high-resolution visuals of 3I Atlas as it approached the inner solar system. Hubble's new observations, taken at just 286,000 kilometers from Earth, displayed something profoundly unsettling: a coma shaped like a teardrop stretching toward the sun, accompanied by an anticola pointing in the wrong direction, jets erupting as if tiny cryovolcanoes were firing from beneath its surface, and structures that did not line up with the nucleus itself. These weren't artifacts or processing tricks. They were consistent across exposures, instruments, and observers. Even amateur astronomers armed with modest telescopes captured bizarre multi-tail formations, including a prominently extended anticola impossible to mistake. But then came the ESA probe's view. 3I Atlas illuminated as a glowing halo with emerging dual tails just days before its closest approach to the sun. The catch? The probe had to use its antenna as a thermal shield, slowing data transmission so drastically that scientists will need months to download everything. That means what we're seeing now is only the beginning. Already, these early images hint at internal processes and structural behaviors that do not fit inside the box of a simple, icy interstellar traveler. Every frame seems to whisper that something else is happening beneath the coma, something directed, precise, and disturbingly consistent. Just when scientists were trying to digest the strange tear-shaped coma, another revelation arrived, and this one hit harder than anyone expected. Astrophysicist Avi Loeb analyzed the new Hubble data and proposed a hypothesis as controversial as it is mathematically compelling. 3I Atlas might be accompanied by a swarm of macroscopic fragments lingering just tens of thousands of kilometers from the main body. These fragments appear to behave differently from the primary object. Specifically, they are unaffected by the non-gravitational acceleration that subtly pushes 3I Atlas off its purely gravitational path. The result? The swarm drifts slightly closer to the sun, exactly as Loeb predicted, aligning perfectly with the shape and extension of the anticola captured in the latest images. This coincidence is statistically razor-thin, and the precision with which the acceleration modifies the trajectory of 3I Atlas is even more suspicious. Loeb argues that such a strangely perfect acceleration profile could, at least in theory, guide the object precisely toward Jupiter's Hill sphere, a region ideal for deploying microprobes or conducting gravitational studies. Natural bodies rarely achieve this level of precision, and while Loeb openly acknowledges the possibility of a natural explanation, he also doesn't ignore the alternative. If the swarm is real, it could represent fragmented material, or it could be something intentionally distributed, working in harmony with the primary object. Scientists attempt to remain cautious, but the mathematics is cold and unforgiving. The behavior does not fit the standard cometary model. Something else is shaping its journey. If the structural anomalies weren't enough, the chemical fingerprint of 3I Atlas shifted the entire conversation to a new level. Radio observations from ALMA detected unusually high levels of methanol combined with hydrogen cyanide, molecules that play critical roles in forming amino acids, sugars, and components of DNA and RNA. This ratio is not common, it is exceptional. It suggests that 3I Atlas is not just a wandering rock, but a carrier of prebiotic material, a seed of life drifting through the cosmos. That by itself would be monumental, but the discovery lands in the shadow of a parallel breakthrough. Samples from asteroid Bennu showed ribose, glucose, and even polymeric structures never seen before, confirming that life's building blocks are not Earth's exclusive property, but universal ingredients scattered across space. When you connect Bennu's organic complexity with the interstellar chemistry of 3I Atlas, the implication becomes inescapable. Panspermia, the theory that life's components spread across galaxies on comets and asteroids, moves from fringe speculation to tangible reality. 3I Atlas carries the chemical signature of a cosmic gardener, spreading essential molecules wherever gravity and time allow. And yet, if this object also demonstrates unnatural precision and anomalous fragmentation, it forces an uncomfortable question. Is panspermia merely a natural process, or could it be engineered? The universe might be far less random and far more intentional than we believe. As 3I Atlas moves toward its closest approaches, first to Earth, then to Jupiter, its behavior becomes increasingly difficult to reconcile with traditional models. Post-perihelion, its brightness began pulsing every 16 hours, not from its faint nucleus, but from periodic outgassing jets synchronized with its rotation like a cosmic heartbeat. Anomalies continue stacking, from its precise trajectory through the planetary plane to its unnerving alignment with Jupiter's Hill sphere. Some researchers remain skeptical, others cautiously intrigued, and a few, like Loeb, straddle the boundary between these worlds, unwilling to dismiss what mathematics and observation keep repeating. Yet something else has shifted. Loeb's tone. The scientist who once openly entertained artificial origin hypotheses appears more reserved now, less willing to commit publicly, almost as if the weight of consequences has finally caught up with the magnitude of his claims. Still, his equations tell a story that cannot be softened. 3I Atlas is unusual, its path improbable, and its behavior deeply inconsistent with natural expectations. In the coming weeks, December, January, early 2026, new data will determine whether this object is a natural cosmic relic or something that challenges the very assumptions on which astrophysics is built. And once it slings past Jupiter, accelerating into the abyss of interstellar space, it may never again be within our reach. This is our narrow window, our only chance to understand whether 3I Atlas is just another visitor, or the first messenger of a cosmic intelligence we have not yet learned to recognize. Among all the strange features 3I Atlas has displayed, the Anticola remains one of the most mind-bending. Unlike a traditional comet tail that streams away from the sun due to solar radiation, this structure stretches toward the sun, defying intuition and revealing the underlying complexity of what is happening near the nucleus. In the latest Hubble and amateur images, the Anticola appears sharply defined, extended, and remarkably stable over time. But what makes this so compelling is not just the visual oddity, it is the physics behind it. The Anticola forms when dust particles are so large and heavy that radiation pressure barely affects them. They drift differently than lighter materials, causing a reversed tail illusion. Yet in 3I Atlas, this structure doesn't just appear logically, it aligns perfectly with the predicted position of Loeb's hypothetical fragment swarm. That means the Anticola is not just a tail, it is a map. It reflects the physical distribution of non-volatile macroscopic fragments that broke away during the object's non-gravitational acceleration. The shape, the consistency, the extension, they echo the mathematical model so closely that dismissing the correlation becomes almost impossible. What we're seeing is the visible trace of an invisible mechanism nudging the object ever so slightly as it moves. And when a deviation is precisely what leads 3I Atlas toward the improbable target of Jupiter's Hill sphere, the Anticola becomes more than a feature. It becomes evidence. Whether the force arises naturally from outgassing or from something far more deliberate, the Anticola is the signature of a journey that follows rules we are only beginning to decipher. When the ESA probe captured 3I Atlas near perihelion, astronomers expected rapid analysis, quick conclusions, and headline-ready insights. Instead, they encountered an unexpected bottleneck. The probe was forced to use its main antenna as a thermal shield to avoid being scorched by the sun. This meant data trickled back to Earth at an agonizingly slow rate, introducing a global scientific suspense unlike anything seen with prior interstellar visitors. That delay has become part of the story. Because while we have only the earliest frames, a luminous halo, indications of dual tails, subtle brightness gradients, everyone knows the true treasure lies in the unreleased instrument data. Spectroscopy, gas density mapping, dust distributions, high-resolution coma geometry. All of it is locked inside a digital vault that Earth will not fully access until February 2026. This creates a unique tension. Scientists can confirm anomalies in real time, but they cannot yet explain them. They can see hints of outgassing patterns, but not determine the exact molecular ratios. They detect structural irregularities in the coma, but cannot yet model the jet dynamics responsible. It is the astrophysical equivalent of watching a mystery unfold frame by frame with the ending withheld. And this delay fuels speculation. What if the forthcoming data confirms the swarm hypothesis? What if it reveals unusual thermal signatures or non-random jet orientations? Or, most unsettling, what if it uncovers behavior inconsistent with natural sublimation? Until the full dataset arrives, humanity is collectively holding its breath, suspended between awe and uncertainty, waiting for the universe to reveal the truth at its own pace. One of the most intriguing developments surrounding 3I Atlas is not an image or a trajectory anomaly, but a change in tone, specifically from Avi Loeb. In the early stages of analysis, Loeb spoke openly about the possibility of artificial origin, drawing comparisons to Oumuamua and highlighting the statistical oddities of the object's behavior. But now, as more data emerges, something about his public posture has shifted. He still acknowledges the improbable precision of the non-gravitational acceleration, the statistically extraordinary trajectory, and the eerie consistency between prediction and observation. Yet his language is more cautious, almost restrained, as if the weight of the implications has forced him into a scientific slow march. This change is striking because Loeb is not someone known for fear of controversy. At this stage of his career, reputation is no longer currency, impact is. So why the sudden caution? Why the softened language? It is possible that the anomalies, while real, still fall within the realm of exotic yet natural behavior. It is also possible that the data is too incomplete for definitive claims. But there is a third possibility, one rarely spoken aloud, that the implications are simply too large to announce prematurely. That the deeper the scientific community digs, the stranger the object becomes, and the more carefully experts choose their words. Whether Loeb is stepping back to avoid early misinterpretation or stepping aside to wait for irrefutable proof, his change in tone has amplified the mystery rather than diminished it. When the scientist most willing to challenge consensus becomes unusually careful, the world pays attention. As 3I Atlas prepares to enter the stage's final act, its gravitational interaction with Jupiter, the scientific world recognizes this as the definitive turning point. Jupiter's Hill sphere is not just a region of influence. It is a gravitational harbor where objects can be temporarily captured, manipulated, or perturbed in highly revealing ways. Natural visitors often pass through with chaotic variability, but 3I Atlas is approaching with a precision that unsettles even conservative researchers. The object's trajectory brings it extremely close to this boundary on March 16, 2026, a date already circled on every astronomer's calendar. What happens at that moment could confirm or collapse years of speculation. If the object releases additional fragments, that behavior would support the swarm fragmentation model. If its trajectory shifts in a way unexpected from purely gravitational interaction, that would strengthen arguments for non-gravitational influence, possibly intentional. If it shows structured outgassing and synchronization with its rotation, that would introduce new layers of complexity in modeling its interior. And if nothing unusual happens at all, then the object will sling into deep interstellar space, becoming a puzzle we will never again be close enough to solve. But for now, Jupiter represents the final checkpoint, the last chance to observe 3I Atlas before it leaves the solar stage forever. Whether natural or engineered, benign or purposeful, 3i Atlas is about to reveal something crucial, something that may reshape how we interpret every interstellar traveler that follows. One of the most intriguing behaviors to emerge after perihelion is the rhythmic pulsing of 3i Atlas, a rise and fall in brightness occurring every 16 hours with impeccable regularity. At first glance, such pulses might be attributed to nucleus rotation, but scientists quickly dismissed that explanation. The nucleus is far too dim to produce changes of this magnitude. Instead, attention turned to periodic jets of gas erupting from specific regions of the nucleus as they rotate into sunlight. This creates a cosmic heartbeat, a repeating expansion and compression of the coma that reveals deeper internal complexity than expected from a fragile interstellar remnant. The remarkable part is not just the stability of the cycle, but the synchronized nature of the jets, as if the object has structurally defined vents positioned in geometrically significant locations beneath its surface. This behavior raises a critical question. Why would an object formed chaotically in a distant molecular cloud evolve such symmetry? Jets are supposed to be messy, irregular, and transient. But 3i Atlas seems to pulse on a schedule, almost like a machine breathing in time with its own rotation. Whether this emerges from internal layering, thermal pockets, or some unknown structural rhythm, the result is a phenomenon that hints at a deeper internal architecture waiting to be deciphered. Another subtle yet remarkable detail emerges when observing the trajectory of 3i Atlas. It aligns almost unnervingly well with the ecliptic plane, the flat disk where the planets orbit. Natural interstellar objects typically arrive at random inclinations, slicing through the solar system at odd angles. But 3i Atlas travels along a path that mirrors the architecture of our planetary neighborhood, as if its approach is coordinated with the gravitational highways of our system. This alignment becomes even more suspicious when paired with its future rendezvous near Jupiter's Hill sphere. Most comets wander unpredictably, but 3i Atlas behaves like a visitor that knows where it's going, threading itself through the solar plane with uncanny precision. This makes astronomers wonder whether the alignment is an extraordinary coincidence, a relic of its origin environment, or the result of the non-gravitational forces subtly shaping its arc. When objects exhibit such calculated movement, it challenges our assumptions about randomness in interstellar trajectories. The more precisely 3i Atlas glides along the ecliptic, the harder it becomes to dismiss the faint whisper that maybe, just maybe, this path is not accidental. While much of the excitement comes from what we've already seen, the real turning point lies just weeks ahead according to the timeline laid out in the document. Between late 2025 and the first weeks of 2026, a flood of data from Mars-based instruments and multiple Earth-bound observatories is expected to arrive. These datasets will offer higher clarity on coma structure, chemical ratios, dust ejection patterns, and possibly thermal anomalies that current telescopes cannot resolve. This upcoming window is critical because the object's geometry, tail visibility, and rotational behavior are rapidly changing as it recedes from the inner solar system. Not only will the angles shift, but the jets that fuel its variations might reveal new asymmetries or collapse entirely as the nucleus cools. Observers know that once 3i Atlas crosses a certain distance, detailed study becomes nearly impossible, and the object begins drifting back into the anonymity of interstellar night. That makes these next observational campaigns a narrow scientific corridor, a brief moment where the universe allows us one last direct look. And everything we have yet to answer about its origin, its chemistry, and its strange dynamical quirks depends entirely on what emerges during this window. The anticipation is not just technical, it is existential. This is the final opportunity to catch the object before it outruns human understanding forever. After its gravitational flirtation with Jupiter in March 2026, 3i Atlas will accelerate outward with such velocity that it will become permanently unreachable. The document emphasizes that once past Jupiter's influence, the object will not encounter any additional planetary bodies capable of altering its trajectory. It will continue outward at tens of kilometers per second, slipping beyond the reach of any probe humanity can launch for generations. This transforms 3i Atlas from a temporary mystery into a permanent enigma, a cosmic message in a bottle drifting back into the ocean of the galaxy. Scientists know that whatever answers are not extracted now will remain unanswered, locked inside a body racing into darkness. The idea that such an anomalous object, one showing irregular jets, a swarm of fragments, precise acceleration, organic-rich chemistry, and uncanny alignment, could simply slip away is almost poetic in its frustration. This is the bittersweet reality of interstellar visitors. They offer glimpses, clues, incomplete fragments of a story older than our sun, and then they vanish into the void. The urgency is not dramatic exaggeration, it is a practical truth. Once 3I Atlas disappears beyond the limits of observation, humanity will be forced to wait for the next interstellar messenger, 4I, whose arrival remains unscheduled by the cosmos. The clock is ticking, and 3I Atlas will not wait for us. In the end, 3I Atlas leaves us standing at the edge of something far bigger than a single interstellar visitor. Every new image, every strange jet, every fragment drifting alongside it, every molecule hiding inside its coma, all of it paints a picture that refuses to fit neatly into any of our comfortable scientific boxes. It behaves like a comet until it doesn't. It follows gravitational rules until subtle forces nudge it into impossibly precise alignments. It carries the chemistry of life, yet moves with the cold, calculated rhythm of something engineered. These contradictions are not signs of confusion, they are signs of discovery. Because what 3I Atlas truly represents is not an answer, but a threshold. A reminder that we are only beginning to understand the theater of interstellar space, and that objects like this, alive with anomalies, pulsing with hidden mechanisms, drifting with improbable trajectories, may be far more common than our brief scientific history has led us to believe. As it approaches Jupiter, as data from probes and telescopes arrives, and as its faint light begins to fade into the dark beyond our system, one truth becomes unavoidable. This object has changed the conversation. Whether its origins are natural or intentional, random or purposeful, benign or extraordinary, 3I Atlas has already forced humanity to reconsider the boundaries of physics, chemistry, biology, and even the possibility of cosmic engineering. And that, in itself, is monumental. It is not the definitive answer people crave, but the spark that ignites deeper questions, the kind that push civilizations to look upward with renewed urgency and imagination. Soon, 3I Atlas will be gone, racing into the abyss at a speed we will never match. But the mystery it leaves behind remains a compass pointing toward our future. A reminder that the universe is not silent, not predictable, not finished surprising us. If this was merely the third interstellar visitor ever recorded, imagine what the 10th will bring, or the 50th, or the 100th. Somewhere out there, 4I is already on its way, carrying its own secrets, its own anomalies, its own challenge to everything we think we know. And when it arrives, we will be watching, ready, curious, changed. If you want to continue exploring these mysteries with us, and if you want to be here the moment the next discovery drops, make sure to subscribe, turn on notifications, and stay with this channel. Because the universe is speaking more loudly than ever, and together we're going to listen.